Okay, in this practice problem, we're going to be looking at a different situation where we've got a simple random sample of weights of women from the data set 1 that comes with a stats crunch, and we have obtained the following sample statistics. So we know we have an N of 55. We have our sample mean of 150.31 pounds, and research indicates that the standard deviation for this particular population is 31.95 pounds. We're being asked to construct a 95% confidence interval. So let's go through the steps for solving this problem. Now we have to apply our flowchart here. So first of all, is sigma known in this situation? Yes, it is. We've been told that it's 31.95 pounds. The population that we are looking at here, we are told to assume that it is normally distributed, but also we also have an N greater than 30. So that means we're going to use the Z distribution table. Now, using the Z distribution table is going to be slightly different than using the T distribution table. So from here on out, there's going to be some variation in our steps. I suggest when you're building your sets of notes to take into the exam that you have one set of steps for if you're using the T distribution table and a completely different set of steps for if you're using the Z distribution table when doing estimation of a population mean. So here we have our Z distribution. Now we're going to identify our Z critical value, and then we're going to plug that in to calculate our margin of error and our confidence interval. So most of this is the same, but the key part that's different is how you use the Z distribution table to identify your Z critical values. So let's pay attention to that now. Be a member of the Z distribution is calculated the cumulative area from the left. This is not the case with the T distribution table. So here with the Z distribution table, we're going to have to take some additional extra steps. So let's look through this example, and if you need to, pause this video, process this information. This is a place where people often get confused, so take your time, go through this several times if you need to. If we had an alpha of 0.05, such as what we have here, we have 1 minus 0.95, and we used the calculated cumulative area from the left, right? So if we're looking at our alpha, so we look at our Z distribution table and we get 0.05 in our body, we go, okay, there's the corresponding area, right, which is our probability. However, we need to get a critical value for both sides, plus and minus, which means we then take that area and we flip it to the right side as well. This would affect double the area. So we'd have so we've got alpha of 0.05, so that's the area there, right? If we take that and then we flip it over to the right-hand side, now we're doubling that, which gives us a cumulative alpha of 0.10, which corresponds with a 90% confidence interval, not the 95% confidence interval we've been asked to solve for. So, take a few minutes here, pause the video, go through this in your head. If you need to, do the numbers yourself to be able to get that to settle into your mind. This is the kind of thing like the central limit theorem. It's really easy to see if you've got an applet that runs it. Otherwise, it's a little difficult to process through. Unfortunately, we don't have an applet for this, so we're just going to have to work our way through it as best as we can. So again, when we're looking at this, if I have my alpha of 0.05 and I get my critical value, my Z critical value for 0.05, right? However, if I use that and I make it as a plus and a minus, which I need to for my margin of error, right? Remember when we do our margin of error formula, we do our confidence interval formula, right? We're going to put it on both sides. That will effectively double the area. So 0.05 suddenly becomes 0.10. This is not the required 95% confidence interval. So how do we solve this problem? In order to keep the final score area corresponding with 95%, we need to take our alpha and divide it by 2. So we're going to take, for 95% confidence interval, we're going to take our alpha of 0.05 and divide it by 2. This gives us 0.025. So we're going to find the critical value for for the area of 0.025 on the left-hand side of the Z distribution table, since they sum to the left. And then we're going to take that same value and we're going to flip it over so that we have both a plus and a minus of that value. Okay, so that's how that's going to work. So if we do this here for this problem that we're working with, we're going to find that to get an area of 0.025, we're going to have a critical value of plus and minus 1.96. Okay? So again, 1.96 corresponds with if the area of 0.025 in your distribution, in your z body of your z distribution table. Following it out, that gets you your z critical value of negative 1.96. And since we're going to be using that for both a left and a right side, because we have a two-tail test going here, we're going to take that and use that as both a plus and a minus 1.96. So for our t critical value here, to go find this, we've got our area of alpha divided by 2, which gives us 0.025. If we go through and locate this in the body of the z distribution table, as we have just done, then we're going to find that we've got negative 1.96, and we use the absolute value of that, 1.96. So now, there's our z critical value. We're going to plug this in to our margin of error formula. So we have our z critical value times, notice now we're using basically the same formula, but we've got a population standard deviation we can use here instead of just our sample distribution. And we're going to divide that by the square root of n. And so we are finished with that. Take a few moments and plug those numbers in, run the calculations, pause the video here till you get your margin of error, and then turn it back on to check your answer. And you should have gotten, as you go through and do these calculations, 8.44. So now once again, we've got our margin of error here of 8.44, and we've got our mean of 150.31. So we can simply plug those into our confidence interval and do our calculation. So pause the video, plug that into your confidence interval formula there at the bottom, and then when you've got your answer, turn the video back on and we'll check it together. So you should have gotten 150.31 minus 8.44, and then 150.31 plus 8.44, which when we go through and solve, we get 141.86, and then 158.75,